In this example, we have to find the length of our unknown sides. In this case, we've got two unknowns, and hopefully we would use a method of similar triangles. So the first thing we need to do is check for similarity in the first place. Now, we probably would be best to look at our angles here. Let's have a look here. These two angles here are vertically opposite, so we know that they're equal. Because I've got parallel lines here and here, using what we know about alternate angles, I know that that angle and that angle are the same. I also know that this angle and this angle are the same. I just need to check whether they're all going to be oriented the same way, so that what I'm going to do is just take this triangle off the top and draw it down the bottom. So if I have a look here, so I've still got my little dot there. What I'm going to do is actually this triangle, I'm going to rotate it around clockwise by 180 degrees. So I'm going to have the angle with the cross down the bottom there, the open circle here. I'm going to have 1.2 on that length. I'm going to have 2 down the bottom still, and I'm going to have my y over there. So this triangle here, when rotated around 180 degrees, will look like that. I can now see that my matching angles, my corresponding angles, are equal. So I can clearly see that I have similarity because all angles are the same. Once I've established similarity, I can now use the other parts of the similarity concept, and that is that all of our sides now should be in the same ratio. So having a look, corresponding sides 1.2 and x are corresponding sides, y and 8 are corresponding sides, and 2 and 10 are corresponding sides. So I need to just use my ratio. Now I can see here that 2 gets scaled up by a factor of 5. So I could use my scale factor, which we know is k, is 10 over 5. So I know my scale factor is 2. So, I should say 5, sorry. Made a big mistake. Let's go back. 10 over 2, so my scale factor is 5. Got myself a bit mixed up there, but you're right. Scale factor is 5, so I know that this triangle here, this big one, is 5 times the size of that. So if I wanted to now find x, I know that x is just going to be 5 times 1.2. On your calculator, you would 5 times 1.2. I know that my length of x is 6. To find y, it's a little bit harder, I suppose. I know that y multiplied by 5 is going to give me 8. So y multiplied by 5 will give me 8. So I know that y is going to be 8 divided by 5. 8 divided by 5. Now remember, if you get a fraction you don't want a fraction, Control Enter will give you the decimal. So y is 1.6. If you wanted to use the scale factor method, that's perfect, but we can also shortcut all of that on our calculator. On our calculator, we can use our solve function. So if we break this up into finding out x first of all, I know that the ratio between 10 and 2 has to be the same as the ratio between x and 1.2. So 10 over 2 has to be the same as x over 1.2. If you do that in a solve, wrap the whole lot up in a solve. So solve that, tell me what x is, you'll be away. So calculator, menu, 3, 1 is a solve. And I've got 10 over 2 equals x over 1.2. Tell me what x is, close the bracket. and you have x equals 6. So it's done all of that in one step for you. So I know that x equals 6. Similarly for y now, let's just look at our corresponding sides. 10 over 2 has to equal 8 over y. 10 over 2 has to equal 8 over y. In a solve menu, 3, 1, 10 over 2 has to equal 8 over y. Tell me what y is in this case. Enter. Y equals 8 over 5, which, as we found out before, was 1.6. Two methods, both giving the same answer. It's really up to you which way you want to do this.